I think we can get started then. Good. All right. So it's time for me to show you this presentation that I've been working on tonight. I'm just kidding. Okay, so this is aggressive PHP QA in 2019. I want to specify in 2019 because if somebody sees this in 10 years, they're probably going to rip their hair off. By the way, is anyone not German speaking? Okay, cool. Yeah, so basically I just want to make sure if you have a question, you don't know how to formulate it, you want to do it in German, feel free to do that. I understand German. I will gladly translate to my degree of knowledge. I'm Marco. This is how I present myself on the internet. So if you see that coming, that's scary. You know your pull request will be rejected. No, I'm just kidding. But I have this ominous presence of Marco is the guy that always says no. Marco is the guy that always finds the problem. Nothing is ever fine. And it's kind of true. I find stuff that other people don't find because I'm trained. Not because I'm smarter. It's just that I do it a lot, so I see a lot. Okay? If I do 20 code reviews a day, I'm going to be more experienced than somebody doing it once a day. And that's very much normal. So I have this ominous presence of I'm the bad guy and I want to kind of fix it. So we'll see how to do that during the talk, or maybe I'm making it worse, I don't know. I'm a consultant. I work for a company called Rove. We're a group of mostly stray dogs that come to your company, get your money, and then spend it to go to conferences. Now, back in time, I did a talk called Extremely Defensive PHP. Did anyone see that? Very few. Okay. Well, if we run out of material, I'm going to start with Extremely Defensive PHP. It's an old talk, but I still remember it. So Extremely Defensive PHP was a set of practices where I said, look, write code this way because you're going to avoid this problem. Write code this way because you're going to be having less trouble understanding and debugging it later. So it was a talk about best practices. There's a lot of discussion around best practices and their validity. Best practices are valid, follow them, and they're called best practices because that's the best we know at the moment. It doesn't mean that they're subjective. They are best practices. Anyone telling otherwise is kind of saying bullshit there. But best practices are contextual to the time where they are active. So, you know, smoke a cigarette every morning because it's going to help you during the day is probably not something you want to do this year. You know, maybe your grandfather did something like that, right? Because they saw it on TV or something. So the talk was from 2014, and it's time to update a few things. So today we talk about software quality assurance specifically. Now, software quality assurance is, and if you go to Wikipedia, is a bunch of mumbo-jumbo about ISO standards. The idea is that you have standards of quality that say, this is a bad thing and should be avoided, and this is what we follow as a practice to make sure things work right, and this is how the software should work according to specification. You try to make a standard, can be subjective, can be some sort of standardized version, but you want to follow it. Now, why quality standards? Who here is a developer? Okay, everyone, kind of, right? So this is a bit redundant. Why quality standards for a developer, right? It always feels like this when you go into a company and they don't have quality standards. So you go in and you say, yeah, here's a wheel. Yeah, but they say, no, thank you, we're busy. We don't have time to implement the wheel because we're stuck working. And I've seen this in many companies, and I've seen it really, really bad, especially in Germany. In Germany, there's this very weird company, well, bureaucratic way of seeing things, where little companies want to behave like corporates, and a lot of people say we always did it that way. It's a very dangerous phrase to use. Don't try to challenge it. Now, what happens is that you go into this vicious cycle. Oh, that's really bad. Oh, now I broke it. So effectively, you got deadlines at the top. When the deadline comes up, everyone is in a haste to get stuff. Yeah, oh, it still works. Okay, so everyone gets work done really quick, very hasty. Once you got the hasty work deployed, since you did it in a hurry, it goes to production, production breaks, and then everyone is spending time firefighting. And by firefighting, you waste time that you should otherwise spend in improving your processes. Not just software processes, but processes in general. So, it is very much well known that it takes an exponential amount of time to fix problems once they reach production. So, if you fix a problem in your software while you're still deciding what to build, that's going to cost you nothing. But if you want to change how the software works after it landed in production, that's going to cost a lot more. It's very obvious, okay? But in practice, what you want to do is you want to keep either this cycle very short, keep it very squished, and make production deployment and development very close to each other, like seconds, or you try to fix as much as possible here. And we are here. This is where we work today. Analysis and design. There are other movements around observability that mostly focus on looking at stuff in production and fixing production and keeping production close to development. That is not exclusive with this talk. You can do that too. This talk is mostly about what you can do. Now, what you do at the beginning of a project, if you find a defect, a problem in the software, you can reduce the cost that it takes to fix a problem to a very minimum effort by either doing something like pair programming or by effectively doing some local continuous integration, which is not remote continuous integration. You don't push and wait half an hour. You're already context switched. You're already on a different problem. You do TDD, and by the way, if you notice, TDD is even further away from pair programming. Pair programming is most effective. Having two people look at the same code and looking at it and reasoning about it means that you constantly have lateral thinking about problems. So you constantly try to attack a bug from different angles. And then you see that you can have parallel testing. I rarely see that. That means you have somebody else doing testing on the side and attacking your software continuously. But you see, now code review is already up here. It's already in red. It's already going high. You know, problems found in code review are already more expensive. Now I have to put in a comment on Friday evening, and you are going to fix it on Monday morning. And there's a weekend in between. Nobody freaking remembers what happened because you had so much booze during the weekend, right? Then there's traditional system testing, which is effectively Amazon Mechanical Turk with QA people. Don't do that. And yeah, traditional acceptance testing. So this still assumes testing, right? We are also in a world where companies still do not do testing sometimes. I say sometimes to make it nice because I know companies don't do testing. They still sell it as a separate line item, and that's extremely unprofessional. To make it clear, quality assurance is not people. The role of the quality assurance person sitting at the computer and reviewing everything that went to production by testing manually everything is bullshit. Don't do that. Those people should be attacking your system by doing pen testing, by trying to figure out UX issues, by trying to figure out how the system breaks in ways that have nothing to do with how the feature was developed. It is mostly up to automated tools to figure out if the system is healthy and keeps running. So it is not a manual and repetitive task. So you shouldn't stay there and have a schedule and test step by step. I've seen that too, you know, Excel spreadsheet, date in the column, and the test to be run, and somebody every morning did this testing by hand. Don't do that. It costs money to run this stuff, and it is going to make people mad, right? Nobody wants that kind of job. That's horrible. And then, absolutely, it's not someone else's problem. As developers, we should take care of the quality of what comes out of our development environment, and we should instead do things ourselves when it comes to repetitive tasks. We are good at automating. We should write the automation around it. We should not drop it on somebody else. Now you see Lisa is visibly pissed here, and that's how the QA department usually feels about the development department. And the development department the other way around. So this entire, drop it on someone else is not really making it nice, nor is going to make friends. That doesn't really help. Right. So the other problem with this traditional testing approach is that effectively, oh, by the way, I wasn't having my slide notes, which makes it a bit harder to understand what's going on. Right, so effectively we have this scenario where the developer mocks out all the data, knows exactly what to avoid, does only the happy path, absolutely no touching everything else because everything explodes. And then when the software goes to this QA department, it comes back as in nothing works. Yeah, it works as expected according to my little feature specification. So yeah, again, not making friends. That's not healthy. That's not building useful relationships between people. So don't do this traditional QA. What did I do? I broke the slides. Yeah. So effectively going back to this kind of diagram, you see you want to keep it this short as possible. You want to keep it on the left of the diagram. That means that the people writing the code are also the people finding the defects as soon as possible. There's a very old paper, well, very old. I wasn't even in software yet. This is Software Defect Removal Efficiency, 1996. They were already looking at this. I don't know how much this applies to modern software, and according to what we do nowadays with TDD, if you do TDD, which is probably 1 in 10 developers, maybe. But effectively, the most defects are introduced during development, of course. You find maybe half of them during development. In practice, what they used to say in clean code is that every 3 to 4 lines of code you have a bug. So imagine that. Now imagine that you have 1 million lines of code running your software because you're running it on the Linux kernel. You don't want to know what's happening in there. And effectively, the cost to repair a defect goes up in 2 magnitudes multiplied by 640 times compared to when you're developing. It's not just a technical problem, it's also a people problem. You are starting to get more people involved in this feedback loop. You're developing, and then somebody else figures out the problem. There's communication. Even during that communication, then there can be misunderstanding, and you're going to add bugs. So traditional software testing is absolutely bullshit, and it is dead. Don't do that. Okay? If you still do that, try to repurpose people doing this QA thing to do exploratory testing, hunting for bugs, not repeating testing, but inventing new tests, inventing new scenarios. Right, so back to who is a developer. Everyone in here was a developer. You need to own your QA hat. You are also QA. Everything you produce should come to a certain degree of quality. We're not perfect. We are still going to introduce bugs. So I'm not expecting anyone to write perfect code, right? And somebody coming to a job interview and saying that they write perfect code, you should never hire those people. But we can start from somewhere. So first of all, you want to start as a team of developers to understand what are you building. There's a talk, I think, by Stefan Priebsch, I think, is doing a talk about what are you building. It's either Stefan or Arne. I always confuse the CC, PHP CC guys. But you want to have a direction where you're going. And that direction should be decided as a team and should be discussed. So this is about collecting requirements and distilling them into a way that is readable and understandable. And at least for me, what worked really well was BDD and domain-driven development. Now, BDD, well, DDD is kind of like the way you talk to business. you should look into it. Has nothing to do with QA, but it helps you understanding what business wants from you and to try and design requirements so that you know what you will have to look for while testing. Okay, if you don't have requirements, then what are you testing against? Right? You can test against stuff that every application has, but if every application has it, why should we buy your software? And BDD is about emerging specifications. So you iterate over what the system does and try to figure out what it should do. And these are the so-called functional requirements, and if you distill them, you get out with documents that are kind of like this. This is a feature file written in Gherkin. It's a specific language that is a very simplified version of English, in which you write examples that are understandable to developers, to technical people, non-technical people, business people. You put these in your project. So if somebody needs to test manually, they take this, they can test manually. Somebody writes automation, they can take this and write the automation for it. But at least you understand what your system is supposed to do. Once you know that, you know what you're going to test against. The second thing, of course, is architecture. So a good architecture is a good ground to build a stable software that works for your use case. It doesn't need to be, every bells and whistles design with CQRS, event sourcing, microservice, whatever. No, there's no need for that. It could be very simple, but the idea is that architecture is about taking decisions and owning them and keeping them throughout the life of the project. If you don't have a good, well-defined architecture, what happens usually is that you start looking at the system and every second file looks different and uses a different design pattern just for the sake of trying it out. So you jump into these projects that have 20 ways of implementing the same thing, even though maybe there was no need for it. So it looks like an experimentation ground, which may be interesting, but it's terrible to maintain. So the architecture is mostly the important stuff. That is kind of what runs your system. It's the layer below. It's what business doesn't care about, honestly, but it's what allows you to be fast and what allows you to keep the system running long term. And I like to call it a non-functional requirement because it's stuff that others don't see. The architecture is kind of uninteresting to people. People come to the hotel, they want to sleep at night. They don't care about how the pillars are put or where the cables are in the walls. That's architecture. Nobody cares about that. There's a very good tool to document and discuss architecture, which is the ADR approach. So it's an architecture decision record. Sounds complicated, but it's really, really simple. In your repository of your project, right, you take and you commit files like these, where you say, here's what we did, this is the background of it, this is what we decided, and this is what's going to come out of it. Negatives and positives documented. So it's very similar to an RFC in a programming language. You want to propose a change to how we do things in the software. Like, tomorrow we make all our value objects immutable. Because this happened, and it's going to bring us this advantage, and it's going to lead to these BC breaks that we foresee will be a pain to fix, but we see value in it. And you take this, send it in as a merge request, pull request, and everyone discusses it. Not some kind of high throne architect role. Everyone in the team owns it. So the point is discussing it. Discussing it, once you discuss it, you document it. In the documentation, you can kind of change a couple lines and whatever, and then you can follow it. So if somebody comes in and says, look, I think it's wrong to do it this way because I think in this particular piece of code it works better this way, you can either point them at the ADR entry and say, this is how we do it, or you can say, write a new ADR in which you propose a new approach. Okay? So you can take something that you took from this conference talk and put it in an ADR inside your project and say, we are going to try doing the way Marco tries to do it. You know, then it's your problem too. Automation. Automation is where we as developers both produce value and reduce jobs. So it has pluses and minuses, whatever. But for me, automation mostly means continuous integration in this case. So in quality assurance, you don't really care that much about how to improve the development environment. You're mostly about verifying that the outcome of that is qualitative enough. There are tools that are about improving the development environment and automating some kind of code fixes and stuff like that, but that's mostly out of scope for the talk today. So what I see as continuous integration, so it's not necessarily the semantical correct way of doing continuous integration, is that you have a set of checks. If all is good, then cool, otherwise exit one. That's CI for me. There's nothing more to it. It's very simple. Now, the tools are important in PHP because PHP is a horrible language. PHP is really, really, really a horrible language, and you can do a lot in it. There are worse languages. You can take Ruby, for example. You know, it's worse. JavaScript. Don't get me wrong. I'm not saying it out of spite. I'm saying it because these languages simply allow you to do too many things. So you have a language that lets you do everything, whatever you want to do. You want to change a function on an object at runtime? Sure, let's replace the prototype of the object. Is it a good idea? Experience says no, okay? In PHP, you can do a lot of things on your objects that are possibly just bad ideas. So that's what's making it a horrible language. I see better languages as languages where you can do less things in very few ways, because they kind of already give you some sort of architecture ground on how to build software. So in PHP, what happens is that experience becomes king. Since the language does not really bring experience with itself, it's more like, here's a bunch of things that everyone used over the years, right? And you figure it out now. So you have to get some expert like me, come over and tell you what's good and what's wrong, right? And I get paid for it, right? If I go into a language that already fixed these problems, then I'm out of a job, which I think is fine. It's just a bit sad. So effectively, the tools that come with the language are, well, the tools that come with the community around the language, the ecosystem, are effectively this kind of knowledge, this experience. The authors of the tools have taken the experience of what is good, what is bad, put it into the tool, and now it's problem solved. You run the tool, and the tool tells you what the decisions are. There's no need to kind of reinvent it. Of course, you can challenge it. You can come up with improvements to the tools, but basically you take this little experience you make on this specific problem, you put it into the tool, now everyone using the tool will benefit from it. So since we rely heavily on the tools, I suggest, that's also my suggestion, go with the MONOREPO. The reason is you don't want to set up PHP unit 30 times for 30 projects. Do it once. There's no point in doing it 20 million times. Multi-repo, you can discuss it. You really need to have a strong use case for multi-repo. Don't do it for the sake of doing it. So once you, assuming you have, let's say that we have isolated one project, one repository. So we are working in one repository. Now, remember, you have to replicate this entire discussion from multiple repositories if that's how you work. We can start introducing tools. So one tool that I really like is Sensulabs Deutschland, Sensulabs die DepTrack. Now, DepTrack is mostly developed by Simon Mönch in Köln. And what this tool does is it takes your sources, analyzes them, categorizes them, so creates clusters of classes such as these are controllers, these are services, this is about payments, and this is about checkout, and puts them in categories. And then you define which category of classes can rely on which other category. So in practice, you configure it with YAML, sadly. And you tell it, okay, we want to analyze sources. We want to exclude anything that looks like a test. We have controllers. So a controller is anything that has controller in its name. Very simple rule, right? Regular expression based. So it works as long as you have relatively good conventions, or you can maybe write your own kind of collector, where you say it's interface based instead of name based. So here we are categorizing things in controllers, repositories, and services. So I took just the example from the README. Okay, I'm not going to tell you how to configure all of DepTrack and how to go fine-grained in it. There is a dedicated talk just about DepTrack. So now that you categorize them, you can put rules on top of them. So you say a controller can depend on services, and a service can depend on a repository. But a repository cannot depend on any other category that is defined here. So you're still free to use other things that are uncategorized, but from the repository, you cannot use these other two. So when you then run the tool, it will generate a nice diagram. And this diagram says, look, in your sources, you have one case where your repository depends on a controller. And that's a violation. You cannot do that. This means use statement. This means doc block. This means type hint. This means dependency. All of these. Nothing is allowed in that way. So it's a relatively simple way to ensure that the junior developer in your company is not going to mix all classes together and just write one of those God classes that does everything. So it encourages layer-based development, which can be seen as both positive and negative. Up to you to decide whether that's nice. You know, take an ADR, write an ADR. This is how we write software. But it will give you this very nice overview of where you screwed up in the dependencies. You introduce it in CI, has exit 1 if there's a violation. It's that simple. So you can pretty much ensure that people don't use the wrong thing in the wrong location. Then comes static analysis. Now, DepTrack is some sort of static analysis, but since it's mostly taking names and wiring them together, I would say it's very little analysis and more like categorization. So for static analysis, there's a bunch of tools. I think there's also Damien at the conference. He's speaking about Exacat. What I usually do is I use these tools. There's Psalm by Vimeo. I think there's a talk about it on Thursday, which is very interesting. Look at it because it's the most advanced type checker that there is in PHP right now, to my opinion. There's PHP Stan, which is the most kind of like used type checker. I don't think it's the more advanced right now, but it is catching up. And I'm personally even a sponsor of PHP Stan, as in I actually gave them money to get a release done, because it is that important to get static analysis into the ecosystem. There's Fan, which I never used because it requires extensions, and I'm allergic to extensions. I don't install extensions in my PHP stuff. I try to run with the bare minimum. And there's PHP Inspections EA, which is a plugin that you install in your IDE, and it mostly gives you this immediate feedback. So you don't need to, push it somewhere or run a tool to get the errors. You see them highlighted in your IDE. And it finds a lot of interesting things about performance, security issues, and so on. So my tool of choice right now is Psalm. It's not because of anything specific. It's just because from my point of view, it is the most advanced one. Now, what do these tools do? They take your code and they basically tell you that it's wrong. That's all they do, right? Whatever you do, if you never installed one of those, you install it now, you run it, it will tell you that something is wrong. It's barely, unless you have an empty directory, you're not going to have code without issues. So don't worry that much about it. So what is interesting is that in type systems, I don't know how many have studied some type theory, but type theory is not about verifying that a program is correct. It's very hard to do that because there are problems like the termination problem, the halting problem, in which you basically cannot demonstrate that the program will stop or not. So there are mathematical limits to what a type system can tell you about your program. But what the type can tell you is that a program is definitely wrong. So a type can tell you up front, look, this is wrong, it will never work, and you will get a crash. So that's very powerful of types. So in practice, you have a set of programs that type check, and the correct programs are always a subset of programs that type check. Whether you then have a type system or not, that's up to you. But a system that renders NaN in the UI is wrong, right? If you have NaN rendered in UI, you know that program is not correct. And that's probably because you mixed apples and oranges with a plus operation. Right, so to install this thing, this is a bit small. Can everybody see this? What is this? What is this letter? Just kidding. Okay. This is making it worse. I press Ctrl+ and this happens. Okay. Don't write your slides in React. It's a bad idea. Okay, so you composer require it. Of course, I prefer using required dev for dependencies. Reason is it integrates well with my update approach for dependencies. People have opinions, but I prefer it this way. So what Psalm does is it takes a bunch of code, like this is obviously simplified. So we have a function foo here. Function foo accepts a string $s, returns void. And then inside we have a return bar. Now, an experienced programmer will obviously say this is bullshit. Now, this is also what Psalm says. So Psalm will say, look, you're returning something, but this function has a void type declaration. So why are you returning something? But it will also look at string. Are you using string $s? And it will say, look, you're not using that. Why is it there? And it will also look at the void and say, look, you have void declared, but the function returns something. Okay. And then it will complain other things. For example, $a has 5 as a first parameter, well, second key, let's say. And then you called function foo with a number instead of a string. And here you called foo without a parameter, even though a parameter is required. These are very trivial issues. The PHP system will catch them and throw exceptions usually. But in practice, this is stuff that you should never need to manually code review. This is wrong up front. That's the idea. You know it's wrong, it's never going to work. Maybe it's going to work, but it's not going to do whatever you expected, so it's still wrong. And that's, again, because PHP is a shitty language. It keeps running when it does things wrong. So it shouldn't be that way. The other thing is, once you start using these rules and using these type checkers, you start writing code in a completely different way. So, for example, what I started doing recently is using this Psalm immutable at the top here. Psalm immutable has been around for a month now, so it's very recent. And now you can declare that this class called price is immutable. And I'm just going to make the price a public property, public int property, and I don't care if it's public, if it needs a getter, or if it's private, or whatever. Why? Because I declared it is immutable. So anything using it that runs through Psalm and tries to write to that property is going to be a violation, and you cannot do that. So it gives you also some freedom. You can now go back into doing public stuff. You can go back into declaring just arrays, and assuming that some key in the array must be there because you can type check that. And the type checker can guarantee that an array with a certain key will be produced. So in that specific scenario, you don't need to invent a new object structure or a new collection type and stuff like that. Interesting for the code quality perspective is that it gives you an inference percentage. Here, I call it type coverage. This is kind of type coverage. So what it says, okay, yeah, it took 3.9 seconds, which by the way is impressive. This is about a library that is like 1 megabyte of sources. So that's very fast for that amount of code, at least from my point of view. But here it says, I inferred 99.7845% of the types. What does that mean? That means that for 0.22%, right? 0.225% of the source, we still have scenarios where the type checker does not really understand fully what is going on in your code, and it just bailed out. That's because PHP is very squishy. If you have an eval statement, you have no idea what the types of anything are going to be in that context. If you have a JSON decode, what is going to be the shape of the data structure that you're looking at? So there is where you need to add assertions and verify the type and teach the type system about the shape of the data that you're looking at. The more you raise this number, the more confidence you will have in what the type checker is doing for you. So if you have like an 80%, you know that your system is doing a lot of shit. 20% of your system is basically shipping around mixed values and hoping that everything works, which is basically just wishful thinking there. So the other thing is you get immediate feedback. This is fast. This is very close to the development cycle. I'm writing code and getting immediate feedback back from it. I'm getting immediate, this is wrong. Works also on legacy projects. So if you got a very legacy project that is like one of those nightmare traps with hundreds of millions of lines that have no sense whatsoever, there's this idea of using a baseline file. Works with Psalm, and now works also with PHP Stan. So you generate a file, and this file is a map of everything that is a known issue in your source. And what you can do is you can configure your continuous integration system to ignore known errors, but not allow new errors, which is very powerful. So you're saying, yeah, the old code is shit, but we're not going to touch it. But anything you write new, please follow the rules. Testing. Now, assuming everything in here does testing, yeah, I mean, okay. The tools that I prefer for this are these three: PHP Unit, bhat, and PHP Spec. PHP Spec not really necessary, I think. It's mostly a style of writing tests. It's more TDD oriented. I never had issues with just testing with PHP Unit and bhat. The reason why I need bhat is that I still have specifications, and I want to use those specifications to have a declaration of what the system does and test against that. But PHP Unit is more than sufficient for most TDD scenarios too. So we are using PHP Unit by Sebastian Bergman and contributors, obviously. There are others, but I'll be honest, I don't really care. There's a lot of tools out there. If you're going to use something like Autom on your test suite, it may be the coolest thing on earth, but you're not going to have anyone actually learning how to use it and how to integrate it with other tools. So before using something exotic, maybe consider starting from this. So this is really hard to read with this projector, by the way. We have, in this case, a system under test. I wrote an example class. This is class myFunction. MyFunction receives an array of numbers, and then it will run in a loop and say, if the number is not a number, then I'm going to throw an exception. So far, so good. Perfectly valid PHP, right? And now I write a test. And in this test, which tests nothing, it tests just that this will throw, we create our function, and we call it with A, B, and C as parameters. Will this pass the test? Yes, it will pass the test. Will it pass CI? Will it pass all the CI pipeline according to rules that we defined so far? Tools that we installed so far? Hopefully not, right? Because this makes no sense. This part makes no sense. We said that this is a list of integers. So why is there a test calling it with a list of strings? This makes no sense. And Psalm will tell us that. It says, argument 1 of my function invoke expects array key int. Instead, we gave it an array with a string, string, and string. Okay? So the type checker says no. So the good thing is you should do testing, and this is not a testing talk, But once you combine it with the other static analysis thing, you can throw away a lot of tests, a lot of checks, a lot of runtime checks, a lot of tests, assertions. Throw them all away. Rely on the type system more than, just runtime. So effectively, yeah, the code is also not valid, by the way. The system under test is also not valid. It says you got a contradiction between int array and trying to reconcile type int to not int, which is not int here. Right? It says this doesn't make sense, effectively. So, again, types are not a runtime problem. You can know upfront if a test or if a system under test is wrong. I had a very lengthy discussion about this with James Titcomb from Rove, in which he said, but Marco, you always say assert everything, never trust the input and whatever. If you have full control from a static analysis perspective on your system, you can simply skip these problems and say, look, you're expected to call it with an int array, you're going to call it with an int array, or I'm going to find out. I'm going to find you and I'm going to kill you. Right? Again, correct programs are already type checked. I wrote a tool about this, spawned from this discussion, which was basically, but Marco, you cannot force people to run static analysis. And I said, or can I? So if you install this, if you're a package maintainer and you have a library, you install this, and what it will do is when people install your package, it will run static analysis against their code, and if there is a violation in their code where it uses your code, it will fail the installation. Composer install will simply say no, which works. I really like that. Then comes quality of tests. And by the way, I'm really, really going slow here. So, are we testing well enough? Now we have my filter here. My filter is a function that receives an integer list, an integer array. We don't really care about what kind of array comes in. And it returns a list of integers. Careful, a list of integers is something very specific. It means it's a packed array. So there are no gaps in it. If you had ever a JSON encode and you skipped a key somewhere in an integer-based array, you know that it comes back as an object and you lost there. So effectively, we're going to do an array values over a filter, and we're going to filter values that are smaller or equal to. So the value must be 3 or bigger in order to pass this filter function. So there is a tool for checking this. So we run a test, first of all. My test that I wrote says, I'm going to have 3 elements when I filter 0, 3, 4, 5. Okay, I expect 0 to be filtered out, but my test simply asserts on the length of the array. It's not doing anything more fancy. I wrote it in a hurry. And then what I do is I run this thing. This is called infection. Infection is a mutation testing framework. Has anybody not heard of mutation testing? Don't worry. Okay, so mutation testing takes your tests, runs them, figures out what code did you run, then it will modify the code slightly, run the test again, and if the test still passes, that means your test is not sufficiently good. Okay? Let's see an example. So, as I said, I had this, my filter, it does an array values of an array filter, and it filters everything greater than 2. Right, and then I have a test, and this test checks that an array of length 3 is produced when I filter 0, 3, 4, 5. Okay? So when I run this, infection will report something like this. It says, I produced 2 mutants that were not detected. So I mutated the code twice, and I still managed to pass the test. So something in your code is not tested well enough. And if we look at the report of it, it will tell us what it changed. So it changed the code. So for example, one of the mutants says, I changed this greater to greater equal, and the code still worked. So you did not test the limit scenario on this comparison expression. And then it will test, in this case, it does something very fishy. You see this array filter? I removed it. I removed array values, and I only left array filter there. Okay, so we're not array valuing the entire structure anymore. And the test still passed. Now, interestingly, will this type check with the new code, without the array values, will this type check? I told you before, our code uses list here. Okay, so careful there, it will not type check. Because now, since we're no longer doing array values, then it means that there may be gaps in our array, in the keys. So this is a limit of mutation testing right now. So it's very powerful to see whether tests are useful or not, and whether you're testing well enough. But on the other hand, it kind of conflicts with static analysis at the moment, because this mutation is valid, but we should never have to write a test for this, because my static analysis guarantees that at least comes out, right? So this mutation is not valid, but we're not running static analysis on the mutations. And that's wishful thinking. So hopefully at some point in the future, we will have a combination of static analysis and mutation testing, where the static analysis knows that a mutant is not valid because it does no longer respect the types of the system. So now that we've done all of this, now finally comes code style. Code style is not that important. It's kind of secondary. What I like to say is pick a base. A good base for now is PSR 12. It came out a couple months ago. But you can pick whatever you like. The point is pick something because it makes code easier to write and read for everyone in the company, because it looks all the same and not, oh yeah, this is Marco's code and this is this other guy's code, and you know exactly who wrote the code before even, actually reading. You just look from far and you see exactly who wrote the code. There's more to it though. I think coding style for basics is cool, but you can use a strict coding style. Now, there are multiple libraries for this, but we wrote in Doctrine, we wrote Doctrine Coding Standard. Doctrine Coding Standard is a strict coding standard. The idea is that, as I told you, PHP allows you to do way too many things in way too many different ways. Let's get rid of some. Let's write in a stricter way. So the talk that I did, that extremely defensive PHP, we took it and we put it in a coding style. It's that easy. Now it's a tool. I don't need to repeat the talk. You just install the tool. It tells you why we're doing things. So for example, here we have late static binding on a constant. We say static A. And what the tool says is, look, you can't do that. Late static binding is disabled for constant because a constant is not in a thing you should override. It's confusing from a developer point of view. It's not an API. Use an interface with a getter on the interface and implement it in a hierarchy instead. It will do things like disabling double assignments. So here maybe you meant to create two datetime instances and assign them to separate variables, but then you happen to have two variables referencing the same object. This is 99% a bug. Simply disallow it. You don't need this sort of feature in the language. Just write a new line with an assignment, and then you know what you did. And it will also do other things that are a bit more fancy. For example, here we have a conditional that is the typical conditional of somebody who wrote code in a haste and did not refactor anything. And you see that that is pretty much redundant. It will simply smash it together and just keep the expression. It will also disable some abominations of the language that are absolutely outrageous. So for example, the extract function, if you don't know what it does, that's probably better. The idea is that you have an array and it will produce variables in the current scope based on the keys of those of that array. And that's horrible. That's absolutely impossible to track. And compact it is the opposite. Compact got some traction with Laravel lately. Don't use that. Don't do that. Compact will take foo and bar and produce an array with keys foo and bar based on the variables in the current scope. Absolutely ridiculous construct. Don't do that. You get, therefore, a simpler language. From the simpler language, you also get some performance benefits, and the static analysis tools will also benefit from it. For performance, there's PHP Bench. Not much to say about it, but if you have code that is very performance sensitive, you can run this on your code. So in my case, this is on run on proxy manager, and what I do is I verify that certain calls stay within certain thresholds. You can run reports, so you can do fancy graphs, and you can dump it into database and do whatever you want with the reports. For me, it is important to show that my library is not adding too much overhead to the language, for example. Speaking of performance, you should have a monitoring and APM system. So yes, this is all nice and shiny on your local computer, but once it hits the fan, when shit hits the fan in production, you really want to know what and why it's slow. And there's a few tools. So for example, there's Datadog out here. If you want to go check them out, that's a good idea if you've never seen an APM. But there's Tideways, which is PHP specific, written by one of the Doctrine people that is now mostly doing that, Benjamin Eberle. There's Sentry. Sentry will tell you what went wrong in your application, produce a nice stack trace, so that people don't have to open a debugger and try to figure out what happened in production. You just get a nice report with a stack trace and everything. And there's tools like Instana and Datadog. They will even tell you that a database query in this system led to a failure in this system, that led to a failure in this system, that led to a failure in this system, that led to 500 error here. And they do that by linking together the requests through systems through a thing called open tracing. So everything gets kind of like, every socket you open gets attached a trace, kind of. So now you got it stable, you got it performant, you got it tested, and everything, you want it stable. To make it stable, if you have an API specification, you should test against that. Don't just write the documentation and hope that the documentation is what your system does, but write the documentation in a way that you can use it as either part of your tests or you can test directly against the documentation. So an API specification allows you that. I had very good success with this LetsNev OpenAPI PSR7 validator. So what it did is it intercepted all requests and responses going back and forth from my testing environment, and it would validate against what we documented in OpenAPI on a system where documentation could not be generated. You want to prevent BC breaks. This is more for package developers. So if you have a package that you release, you can use this Rove backward compatibility check, and this will tell you basically, no, you can't do that unless you raise the major version. And it will figure it out for the grand majority of changes in your API. So in this case, you run it. You say, I want to check from version 2.6.2 to master. Tell me if there are BC breaks. So you can put it in your CI, and it will tell you, look, I removed this function. And here it will say, look, the parameter association mapping of this function changed from array to a non-contravariant association metadata. What that means is out of scope for the talk, but it's basically telling you, look, you changed the type declaration for that parameter, and that's a BC break. Now you got this table, keep it updated. You cannot update your system if you don't know if you're going to break it. So please, first do the other things, then work on updates. There's Dependabot. I love Dependabot, even though it spams my inbox. Dependabot works on GitHub. And basically, every Monday, I get something like 50 emails about here's things that I updated. And it's usually about Symfony, because Symfony can't manage to do one release, only when it's needed, but it needs to release all the packages all the time. I find it annoying, but whatever. So effectively, I update all the packages regularly. And this way, I know exactly which package broke what in my system. And it is very powerful, because I can help other maintainers understand whether their system broke because of what they changed in a minor release or something like that. There's security advisories. Security advisories is a single composer JSON. It's a project you require, and it will prevent you from updating to dependencies that have known security issues. That's it. There's no API nor CLI, you just require it. You can no longer install stuff that is affected by security advisories. And then there's two tools that I also help developing. One is Matthias Glaub's Composer Require Checker. This will tell you if you have code that depends on stuff that is not declared in your composer JSON. So what can happen is very dangerous. You have a dependency that is installed by accident, you're relying on it, but then you forget about it, and during an update, that dependency disappears, and your local code no longer works, right? So it should be in your composer JSON. There's the opposite, composer unused. It will figure out that you have dependencies that you're not using. It will do the same. Right, so I spoke a lot. So, interesting reference table. These are advices of tools that you can import in your projects, install. The idea is that you automate tasks. Keep in mind that automating tasks does not mean that the work goes away, because these tools are tools. They're written by humans. They will fail. And when they don't do what you want, you will hate them. And you may waste more time than what you saved in implementing them. So always keep this reference table. How many times a day am I doing something? How much does it take? And is it worth automating? For tools that already exist, that's fine. Install them. Give them a try. I also redefined the kind of dependency, the requirements pyramid of your project. First of all, make it work, then make it nice, then make it fast, then keep it stable, and finally keep it updated. I think this is kind of what the system should do. You start from below and work your way up in the pyramid. And I think when you want to look at it in more detail, in steps that you want to do, is first of all, you need to have requirements, and these requirements need to be agreed upon by the team. If you don't agree on requirements, you already have a bug there. It's called people. That's the bug you have there. Once you got that, you need an architecture. If you don't have an architecture, you basically got WordPress. After that, you keep static analysis. Static analysis ensures that your architecture is kept in place and it makes sense. With the static analysis, you can then go on and implement tests and verify the quality of your tests. Once you got a system that is tested, you can use stability if you need stability. If your system is not used only by you but also by others, you need to guarantee this stability. Once you got stability, you can automate updates, which basically means daily composer update. That's really all you need to do. You do a daily composer update. If you got stability and you got tests, you can do that all the time. You can run on PHP trunk. You don't even need to wait for releases as long as you test stuff. And then code style. Code style is not that important, as you see. It's really at the end of the pyramid. Okay? So there's a lot of stuff in between. And what I usually see is people putting code style down here and then working everything up. And it's a nightmare. Important to say, PHP is no longer an interpreted language. We always go through the Docker build process. We always go through the CI process, make a package, upload it somewhere, do a deployment of some way. We no longer log into a server, change a couple lines, and see what happens. That's not what we do anymore. Okay? So these tools take time. Try to make them fast, but it is okay to have a build time at this point. And even if it looks like a different language at the end of the day, it's still much safer to work this way. Okay. Thank you very much. I'm really sorry I don't have much time for questions, and I'm also holding you off from lunch. But feel free to come over here and ask any question if you want to delay your lunch. Thank you very much.